Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have 3 to the power of a minus 2 to the power of a is equals to 65, and we solve this problem for all the values of a. So here first we rewrite this equation as here we will just multiply and divide the exponents of both of these two terms with 2. So this will be written as 3 to the power of a, and its exponent is 2 divided by 2, minus in the same pattern we write this term as 2 to the power of a, and its whole exponent is 2 divided by 2 equals to 65. And now here further in the next step we move the term 1 over 2 inside the terms, and it will be written as 3 to the power of, when we move the exponent 1 over 2 inside the term, it will becomes here 3 to the power of a divided by 2, and its whole exponent is 2, minus this will be written as 2 to the power of a divided by 2, and its whole square is equals to 65. And now here we need a little bit substitution here in order to write this equation into the simplified form, or in other words we just convert this exponential equation into the two variables polynomial equation. So that here we will take x is equals to 3 to the power of a divided by 2, and we take y is equals to 2 to the power of a over 2. So now we substitute both of these two values to the above equation, and our above equation is written as in this form. This will becomes x square minus this will becomes y square is equals to 65. And you see that our left hand side becomes very famous algebraic formula. You know about that: x square minus y square equals to x square equals to x minus y times of x plus y, and this is equals to 65. So here you see that in the left hand side we have two factors are multiplied by each other, but in the right hand side we have only one factor. So we need to find any positive integers whose product becomes 65. So these possibilities are 1 times of 65 equals to 65, and 65 times of 1 equals to 65, and 13 times of 5 is also becomes 65, and 5 times of 13 is equals to 65. So we have, these are the four possibilities in which we get the product of two positive integers becomes here 65. But if we make the relation between these two factors, we say that the first factor x minus y is always less than or equals to x plus y. So we just choose only those pairs of values in which the first integer is less than the second integer. So if you see here 1 and 65, so 1 is less than 65, so we accept this case. But if you see here 65 is greater than 1, so we rejected this case. Similarly, this 13 is greater than 5, so we rejected this case because the first factor is greater than the second factor, but we need those factors in which the first number is less than the second number. Okay, so this is 5 times 13, and we know that 5 is less than 13, so we accept this case. So finally we have, there are two cases, there are two possibilities, or so that we divide our given equation into the two forms. So the first case is written as, we compare these two factors with 1 and 65, and it will be written as x minus y equals to 1 and x plus y equals to 65. Here we write the second case. So in the second case we have x minus y equals to 5 and x plus y equals to 13. So we need to solve both of these two cases, and we get the values of x and y, and we back when we move backward and we get the values of a. So here first we called, this is our equation number 1, this is our equation number 2, and this is our equation number 3, this is our equation number 4. So we solve all these four equations and we get the values of x and y. So first we sum up equation number 1 and equation number 2. So because here our target is to only get the value of a, so when we add these two equations, we get x plus x becomes here 2x equals to 1 plus 65 becomes here 66. So for the values of x, we divide both of the sides by 2. This 2 and 2 are gone. This is 2 times 3 becomes 6 and 2 times 3 becomes here 6. So if here we easily get the value of x is equals to 33. And now in the same pattern we just put this value of x into the equation number 1 and we get the value of y. So equation number 1 becomes here 33 minus y is equals to 1, and we get 33 minus 1 equals to y. So we easily get the value of y is equals to 32. So this is the value of x and this is the value of y. But now here first we need to find the values of x and y from this case, and then we move forward. So here we add equation number 3 and equation number 4. So we get here 2x is equals to 5 plus 13 becomes here 18, and we get the value of x is equals to 9 after dividing both sides by 2. Okay, so here we put this value of x into the equation number 3, and our equation number 3 becomes here 9 minus y equals to 5, and 9 minus 5 equals to y. So we get the value of y is equals to 4. So this is the value of x. So here in the first case, we from both of these two cases we get here the values of x and y. And now first we copy down both of these two values here. So in the first case we get the value of x is equals to 33 and the value of y is 32, and from second case we get the value of x is equals to 9 and the value of y is equals to 4. But now here we move backward and we substitute the value of x and y into the both of these two cases. So we have the value of x is 3 to the power of a divided by 2 equals to 33, and the value of y is 2 to the power of a over 2 is equals to 32. So here in order to get the values of a, we need to take log on both of the sides. So when we apply natural log on both of the sides, we will get here this will becomes log of 3 to the power of a over 2 equals to equals to log 33. And similarly we just call this is our equation number static, so we can solve this after solving this. So here we use the property of log and we move a over 2 into the front of this log, and it will becomes a over 2 times of log 3 is equals to log of 33. So we move all these values to the right hand side and we get the value of a is equals to 2 times of log 33 divided by log of 3. This is the first value of a. And now we solve the static case, and here we apply. But now you see here from this case we cannot get the integer values of it, because in the start of the problem I can say that we solve this problem for only integer values. This will not gives us the integer solution, so that we rejected this case and we will just proceed here this case only. So here we use these two values and we get here 3 to the power of a over 2 equals to 9, and the value of y is 2 to the power of a over 2 equals to 4. So here we write 9 as 3 square, and when we compare both of the sides we get a over 2 equals to 2, and we easily get the value of a equals to 4. This is the first integer values of a. So now for this case we rewrite the right hand side as this is 2 to the power of a over 2 equals to 2 square, and we get here a over 2 is equals to 2, and from this case we again get the value of a is equals to 4. So here we just get only one integer solution, and that is equals to 4, and finally we have the solution set of the given question is a equals to 4. This is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.